Hey guys, tonight we are doing something a little different. We are not trudging through mud, sleeping in a barn or dodging the plague. No, tonight we're going somewhere far more clinical, far more modern, and arguably just as dangerous. Tonight we're talking about Demerol, the drug that was supposed to be better than morphine. Faster, cleaner, safer, less addictive. A pharmaceutical fairy tale written in a lab by a German chemist who had no idea what he had just unleashed on the world. Spoiler alert, it was not better than morphine. It was in many ways substantially worse. It was just better at convincing everyone otherwise for about 60 years. Before we get into that, a genuine thank you to the viewer who suggested this one. You know who you are, and you clearly have excellent taste in pharmaceutical catastrophes. This channel runs on your curiosity, and that means more than I can say. If you enjoy what I do here, please like the video and subscribe, but only if this is genuinely your kind of thing. Leave a comment telling me where you are listening from and what time it is, and if you have been sleeping to this channel on Spotify, there is a link in the description. We are over there too, waiting for you at 2 in the morning like a responsible chemical dependency. Now, dim the lights, turn on the fan, pull the blanket up to whatever specific height makes you feel safe. Get comfortable. You have earned it. Because before we drift off, let us sit with a few questions. Have you ever wondered how a drug gets labelled safer before anyone has actually tested whether it is? Have you ever thought about what it must feel like to be a labouring mother in 1953, strapped to a hospital bed, receiving a painkiller that causes hallucinations and makes you forget the entire experience? Have you ever asked yourself how a pharmaceutical company sells a product for 6 decades, watches the evidence pile up that something is very wrong, and just keeps going? Did anyone in a lab coat ever stop and say, wait, the metabolite might be the problem? And if they did anyone listen? And what does it say about modern medicine that one of the most widely administered drugs in American hospital history turned out to be quietly, persistently, neurotoxic? Congratulations. You've just been admitted to a hospital in 1955. The nurse is cheerful, the doctor is confident, and the syringe being prepared for you contains a synthetic opioid that everyone agrees is a major step forward. They're not entirely wrong. They're just very, very wrong about the important parts. Sleep well. The year is 1939, and a German chemist named Otto Eisleb, working for the pharmaceutical giant IG Farben, is not trying to change the history of pain management. He's running experiments on antispasmodic compounds, looking for something that might relax smooth muscle, the kind of thing that would help with intestinal cramps or the trachea during surgery. What he synthesizes instead is meperidine, a molecule with an unremarkable name and an extraordinary property. It binds to the brain's opioid receptors with a power nobody expected from something that did not look like an opioid at all. Nobody is more surprised than Otto Eisleb. Nobody is more delighted than IG Farben. Here is what makes this moment genuinely strange, if you think about it long enough. Eisleb was not looking for a painkiller. He was not standing in a laboratory with a morphine molecule on the wall and a whiteboard full of structural modifications. He stumbled into one of the most consequential pharmaceutical discoveries of the 20th century, the way you might stumble into a furniture corner in a dark room. Suddenly, painfully, and with long-lasting consequences nobody anticipated. The compound he produced had a chemical structure that looked nothing like the opium-derived painkillers medicine had relied on since the early 19th century. Morphine, codeine, heroin, these are all structurally related, variations on the same molecular theme, recognizable to a trained chemist as belonging to the same family. Meperidine looked like a different family entirely. It was a piperidine derivative, simpler in structure, almost disappointingly modest on paper, and yet when it was tested in animals it produced analgesia, pain relief, with a potency that was impossible to ignore. This is the part of the story where a reasonable person might expect caution. A new molecule that behaves like a powerful opioid despite looking nothing like one is either a scientific breakthrough or an invitation to disaster, and distinguishing between those two outcomes requires the kind of slow, systematic investigation that the pharmaceutical industry in 1939 was not structured to provide. IG Farben was structured to find things, patent them, and figure out the complications later. To be fair, this was not unusual. It was the industry standard. The compound was patented in Germany in 1939 under the name pethidine. Early reports described it as having roughly 1/10 the potency of morphine, which made it sound manageable, approachable, reasonable. What those early reports did not describe, because nobody had looked closely enough yet, was what happened when the body started breaking it down. The metabolite question, the normeperidine problem, the seizure risk, all of that was sitting quietly in the molecular structure waiting to be discovered. Nobody was looking for it because nobody thought to look. They were too busy being excited. Think about what it feels like to find something at a garage sale, convinced you have spotted something valuable, and you carry it home, you put it on the mantle, and for years everyone admires it. Then one day, someone who actually knows what they are looking at comes over, peers at the bottom of it, and very gently explains that it is not what you thought it was. That is roughly the arc of meperidine's first decade in the world, except the stakes were considerably higher than a garage sale find, and considerably more people were affected. By 1940, IG Farben had enough preliminary data to believe they had something worth developing. The antispasmodic effects were real. The analgesic effects were real. The compound was synthesizable, patchable, scalable. A molecule that started life as an accidental observation in an antispasmodic screening program was about to become one of the most widely administered drugs in the history of modern medicine. Otto Isleb went back to his bench. The machine of pharmaceutical development started turning. And somewhere inside the structure of that modest little piperidine ring, the future was already written. Here is the thing about meperidine that made scientists in 1940 so genuinely, almost touchingly excited. It did not look like morphine. It did not come from a poppy. It was not extracted from anything. It was synthesized in a laboratory from scratch, which meant, at least in theory, that the parts of the molecule responsible for addiction and respiratory depression could simply be designed out. The thinking was elegant and almost entirely wrong, but it would take decades for that to become obvious. In the meantime, a synthetic opioid that worked like morphine but was built from chemistry, rather than agriculture, felt like exactly the kind of progress the 20th century had been promising. You have to understand the context in which morphine was viewed by 1940 to appreciate why any alternative looked attractive. Morphine had been extracted from the opium poppy since the early 1800s, and had been in clinical use long enough for its problems to be well documented, if not well managed. It caused respiratory depression. It caused constipation. It caused nausea. It was addictive in ways that the medical profession had observed for over a century, and responded to with a combination of moral judgment, inadequate treatment, and periodic legislative panic. The Harrison Narcotics Act of 1914 had created a regulatory framework around opioids that made physicians deeply cautious about prescribing them, sometimes to the point of undertreating pain in ways that caused significant suffering. Into this landscape came meperidine, synthetic and promising, wearing its structural novelty like a clean shirt at a job interview. The argument for it was not just that it worked. Morphine worked, everyone knew that, but that it worked differently, which implied it might fail differently too. If the addiction liability of morphine was connected to its specific molecular architecture, then a structurally dissimilar molecule might carry less of that liability. If the respiratory depression came from particular receptor interactions, perhaps those could be avoided. These were reasonable hypotheses. They turned out to be largely incorrect, but they were not unreasonable. This is one of medicine's recurring patterns, and it is worth pausing on. The history of pharmacology is lined with drugs that were celebrated precisely because they were different from whatever came before. Different meant modern, different meant improved, different meant that whatever went wrong last time had been corrected by someone in a laboratory who thought harder than the people before them. The implicit assumption that novelty implies progress was almost never examined critically because it was culturally invisible. Of course, the new thing was better. Why else would you make it? The early clinical reports from German physicians using meperidine in the late 1930s and early 1940s were, by the standards of the time, encouraging. Patients reported pain relief. The drug worked faster than morphine when injected. The duration of action was shorter, which could be framed either as a limitation or as an advantage depending on what you needed. Respiratory depression appeared to be less severe at equianalgesic doses, though the comparison methodology used in those early studies would not survive modern scrutiny. What was not examined, because the tools to examine it did not yet exist in clinical routine, was what was happening downstream. The body was receiving meperidine and converting it, step by biochemical step, into normeperidine. The normeperidine was accumulating. Nobody was measuring it because nobody had a reason to look. The drug appeared to be doing what it was supposed to do. Patients were reporting relief. Physicians were reporting satisfaction. The molecule sat on its receptors and produced its effects and kept its metabolic secrets tucked away, waiting for the conditions, repeated dosing, impaired clearance, long courses of treatment that would eventually bring them to the surface. For now, the future of pain relief had arrived. It looked clean. It looked modern. It looked nothing like the thing it was about to replace. That was the whole point. By the time meperidine crossed the Atlantic, it had been repackaged, renamed, and handed to the American market by Winthrop Stearns, with the kind of confidence that only a pharmaceutical company in the 1940s could muster. The new name was Demerol, and it was chosen to sound clean, precise, and vaguely European, which in medicine at that time was the same as sounding authoritative. The marketing was careful, the claims were ambitious, and the underlying message was consistent. This is what comes after morphine. Morphine is the past. Demerol is what responsible modern medicine looks like. Doctors listened because doctors in 1947 had very little reason not to. The mechanics of how a drug becomes a name brand rather than a generic compound is worth understanding, because it is central to how Demerol embedded itself in American medicine so thoroughly that it took 60 years to begin extracting it. Meperidine the molecule belonged to anyone who wanted to study it. Demerol the brand belonged to Winthrop Stearns, and Winthrop Stearns had marketing infrastructure, sales representatives, and a very clear commercial incentive to make sure that when a physician reached for a syringe, the name that came to mind was theirs. Pharmaceutical detailing in the 1940s and 50s was a different enterprise than it is today, but the basic shape was familiar. Sales representatives visited physician offices, left samples, distributed literature, and built the kind of personal relationships that, in an era before evidence-based prescribing guidelines and formulary restrictions, translated directly into prescription behavior. The claims made in Demerol's promotional materials during its early American years emphasized speed of onset, shorter duration of action, and the much-repeated suggestion that it carried less addiction potential than morphine. The last of these claims was the most consequential and the least supported, but it was also the most appealing in a medical culture that had spent decades managing morphine's legacy of dependency. You're a physician in 1949. You have a patient in pain. You have spent your career navigating the regulatory and ethical tangle around morphine, the Harrison Act, the fear of creating addicts, the social stigma attached to opioid prescribing, the formal and informal pressures that made heavy morphine use professionally uncomfortable. And now someone is telling you that there is a synthetic alternative, modern and laboratory-built, that provides comparable pain relief with less of the baggage. This is not a difficult sell. This is the kind of thing you recommend at the next hospital staff meeting. The name itself did work that the molecule alone could not do. Meperidine sounds like a chemical. Demerol sounds like a medication. Finished, validated, ready to be trusted. Names in medicine carry authority in ways that are easy to underestimate. Generic names carry the flavour of the laboratory. Brand names carry the flavour of a process that has been completed, reviewed, approved, and rendered safe for human use. This is partly justified. The approval process does provide some of those assurances, and partly a manufactured feeling, a carefully constructed identity for a molecule that was, underneath the branding, still doing the same uncertain biochemical things it had always done. By the early 1950s, Demerol was in hospitals across the United States. It was in surgical suites and labour and delivery wards and post-operative recovery rooms. It was in the emergency department and in the medicine cabinet of private physicians who made house calls. It had, in a remarkably short time, achieved the kind of clinical ubiquity that pharmaceutical companies dream about. It was not just a product, but an expectation. When patients arrived in pain, Demerol was the answer that came to mind. Not because the evidence demanded it, because the brand had done its work. If there is a single chapter in the Demerol story that requires you to sit down before you hear it, it is this one. For roughly 4 decades, from the late 1940s through the 1980s, Demerol was the standard pharmacological intervention for women in labour in American hospitals, not as an option, not as a last resort, as the default. It was administered routinely, often without detailed discussion, to millions of women who were told it would take the edge off. What it actually did was cross the placenta, sedate the fetus, depress newborn respiration, and leave many mothers with no memory of giving birth to their children. Everyone involved agreed this was progress. The mechanism by which Demerol came to dominate obstetric pain management in post-war America is not a story of deliberate harm. Nobody sat in a boardroom and decided to give labouring women a drug that would sedate their newborns. The story is more mundane and in some ways more disturbing than that. Demerol arrived at the right institutional moment, carrying the right set of claims in a medical culture that had already decided certain things about women in labour that shaped everything that followed. The hospital birth itself was a relatively recent phenomenon by the 1940s. For most of human history, childbirth happened at home, attended by midwives, family members, and whoever else the situation required. The medicalisation of birth, its migration into hospital settings, under the authority of physicians, within institutional protocols, accelerated dramatically in the early 20th century, driven partly by genuine improvements in maternal and infant mortality, and partly by a professional project of consolidating obstetric care under medical authority. The woman giving birth was, in this framework, a patient. Patients were managed. Management meant medication. Into this framework, Demerol arrived with impeccable timing. It was injectable, fast-acting, and carried the reassurance of being a newer, better-controlled alternative to the morphine scopolamine twilight sleep that had preceded it. The claim that it was safer for the fetus than morphine was repeated widely and accepted readily. It was not, in any meaningful sense, supported by the quality of evidence that would later be considered minimally adequate for such an assertion. But the evidentiary standards of the era were not the evidentiary standards of today, and physicians who were genuinely trying to do right by their patients accepted the claim in good faith. What this meant in practice is something that is uncomfortable to reconstruct. Women who were given Demerol during labour frequently experienced profound dissociation, confusion, and amnesia. Some reported the sensation of being present in their bodies but unable to make sense of what was happening. Others reported later that they had no memory of the birth at all, that their first child's arrival existed for them only as a story told by someone else, a gap in their own experience of a moment that was supposed to be definitive. The newborns, for their part, arrived with measurable respiratory depression and reduced muscle tone, effects that were documented, attributed to maternal opioids, and treated as an acceptable trade-off for pain management, rather than as a signal that the pain management approach required rethinking. Think about what you would feel if you found out that the most significant physical event of your life had been chemically removed from your memory, not because it was necessary for your safety, but because the prevailing medical opinion of the time was that you did not need to experience it fully, that the management of your experience mattered more than the experience itself. That is the conversation American obstetrics largely avoided having for 4 decades. Demerol made it possible to avoid having it. That was, in a sense, part of its function. To understand why Demerol slid so effortlessly into obstetric wards, you have to understand what came before it. In the early 20th century, American hospitals had enthusiastically adopted a method called twilight sleep, which combined scopolamine and morphine to render labouring women amnesiac and dissociated. The idea was not pain elimination so much as memory elimination. If the woman could not remember the pain, the argument went, it was as good as if the pain had not happened. This logic, which sounds like something a philosophy student would reject in the first 10 minutes of an ethics class, was taken completely seriously by the medical establishment for decades. Demerol inherited this tradition not by accident but by design. Twilight sleep had been imported from Germany in the early 1900s, where it had been developed at a clinic in Freiburg by 2 physicians who believed they had solved the problem of labour pain in a single elegant move. The solution was not, strictly speaking, to eliminate pain. The solution was to eliminate the woman's ability to form conscious memories of the pain. Scopolamine, a powerful anticholinergic drug derived from plants in the nightshade family, produced amnesia. Morphine provided some degree of analgesia. Together they created a state in which a woman could be fully awake, fully experiencing the physical process of labour, screaming, thrashing, and requiring physical restraint, a detail mentioned in contemporary accounts with a casualness that is startling to a modern reader, while being incapable of forming lasting memories of the experience. The women who advocated for this treatment were not victims of false advertising. They genuinely did not remember the pain. From their perspective, twilight sleep had worked. They went in, something happened, they came out with a baby. What they were not in a position to advocate for because they had no memory of it was whether the experience itself, the part they did not remember, had been acceptable. The nurses and physicians who were present for that part left accounts that were considerably more troubled. The dissociation was sometimes severe. The physical restraints required were sometimes extensive. Women tied to padded cribs, thrashing through contractions, fully conscious in the sense that their bodies were responding to sensation, but absent in the sense that no narrative self was integrating the experience. This was, by 1910, a mainstream American hospital practice. Twilight sleep's decline came not primarily from ethical objections, but from accumulating evidence of maternal and fetal harm, including elevated rates of newborn respiratory depression and, in some cases, maternal deaths from the combination of drugs. It was replaced not with something categorically different, but with something that made the same essential promises in a slightly more manageable package. Demerol, faster and shorter acting, amnesiac in higher doses, could be titrated more precisely and carried less of the stigma that had accumulated around the morphine-scopolamine combination. It was, in the eyes of the physicians who adopted it, an upgrade. The underlying philosophy that a woman's subjective experience of her own labour was a clinical problem requiring pharmacological solution remained entirely intact. This is the tradition that Demerol entered when it moved into obstetric wards in the late 1940s. Not a blank slate, but a furnished room. The furniture was the idea that labouring women needed to be managed, that their pain required suppression, that their memory of the event was an acceptable casualty of comfort, and that the physician's judgment about what constituted an adequate birth experience superseded the patient's own. Demerol did not create this furniture. It simply moved in and made itself at home. Here is the part of the Demerol story where things become genuinely difficult to explain in flattering terms. Meperidine, when your body processes it, produces a metabolite called normeperidine. This is not a minor footnote. Normeperidine is a central nervous system stimulant, not a depressant, and it accumulates in the body over time, particularly in patients with impaired kidney function, elderly patients, and anyone receiving repeated doses. Accumulated normeperidine causes tremors, agitation, mood disturbances, and, if allowed to build up long enough, seizures. The drug that was supposed to be milder and safer than morphine was, under repeated dosing conditions, capable of giving you a seizure. This was not a secret uncovered in 2010. The evidence existed far earlier than the field was willing to act on it. Metabolism is the process by which your body takes a foreign compound and breaks it down into smaller pieces, which can then be excreted. The liver performs the bulk of this work, running incoming molecules through a series of enzymatic reactions that progressively dismantle them. Most drugs produce metabolites that are either inert, chemically inactive fragments waiting to be eliminated, or significantly weaker than the parent compound. Meperidine does something different. It produces normeperidine, which is pharmacologically active in its own right, and active in ways that are not simply a diluted version of what meperidine itself does. Normeperidine is about half as potent as meperidine as an analgesic. So far, fine, but it is significantly more potent as a proconvulsant, a substance that lowers the seizure threshold and increases neural excitability. Its half-life, the time it takes for half the dose to be eliminated from the body, is substantially longer than meperidine's own half-life. Meperidine itself clears the body in a few hours. Normeperidine takes significantly longer, and in patients with reduced kidney function, the elderly, those with chronic illness, those with kidney disease, it can accumulate over days of dosing to levels that are genuinely dangerous. The picture this creates, if you hold it in your mind for a moment, is somewhat counterintuitive. A patient receiving Demerol every few hours, as was standard practice in post-surgical wards for decades, is simultaneously receiving what appears on the surface to be adequate pain management. The meperidine is providing analgesia, while quietly accumulating in the background, a compound that is working in the opposite neurological direction. As the meperidine doses stack up, the normeperidine level rises. The patient may report reasonable pain control. The physician may see reasonable vital signs. And somewhere in the patient's nervous system, the seizure threshold is being steadily eroded. The early observations of this problem were not secret. Case reports describing tremors, myoclonus, involuntary muscle twitching, and seizures in patients receiving repeated meperidine doses began appearing in the medical literature as early as the 1960s. The reports were consistent enough, and the proposed mechanism clear enough that anyone reviewing the literature systematically would have found them. The difficulty was that reviewing the literature systematically required someone to be asking the question, and the question was not being asked with any particular urgency, because the problem was not visually obvious at the bedside. A patient who develops a tremor on day 3 of post-surgical Demerol is, in a busy hospital ward, a patient with a tremor. The list of possible causes is long. The meperidine connection requires either clinical suspicion, informed by pharmacological knowledge, or a protocol that specifically prompts nurses and physicians to consider drug toxicity when certain neurological symptoms appear. Neither was standard in the decades during which Demerol was most widely used. The drug kept being given, the normeperidine kept accumulating, the connection kept being missed, and somewhere in a filing cabinet in a medical library, the case reports kept adding up. One of the underappreciated reasons Demerol remained in widespread use for so long is not pharmaceutical, it is bureaucratic. Once a drug makes it onto a hospital formulary, the official approved list of medications that nurses and physicians can order. Removing it requires evidence, advocacy, committee meetings, and the slow turning of institutional wheels that were not designed for speed. Demerol entered formularies in an era when the normeperidine problem was either unknown or underappreciated. By the time the evidence against repeated dosing was clear enough to act on, the drug was embedded in workflows, nursing protocols, post-surgical order sets, and the clinical muscle memory of an entire generation of healthcare providers. The inertia of the standard of care is one of medicine's most reliable and least discussed hazards. A hospital formulary is not simply a shopping list. It is an artifact of institutional authority, professional consensus, and, in many cases, contractual relationships with pharmaceutical suppliers. Drugs are added to formularies through a process that varies by institution, but typically involves a pharmacy and therapeutics committee, a body of physicians and pharmacists who review evidence, consider costs, and make decisions about which medications will be available for clinicians to order. The process is designed to be careful. It is also designed, implicitly, to add things. The processes for removing things are less well-oiled because the political economy of removal is considerably more complicated than the political economy of addition. When a drug is added to a formulary, it has advocates, the pharmaceutical company, the physicians who trialed it, the clinical champions who believe in it. When a drug needs to be removed, the advocates for removal are typically safety professionals, pharmacists, and clinical specialists who have done systematic work, while the advocates against removal are often the entire clinical staff who have been using the drug for years and have built their practice patterns around it. This is not a conspiracy. It is just the ordinary friction of institutional life, and it is extraordinarily effective at maintaining the status quo. Consider what it actually looks like to change a post-surgical pain management protocol in a mid-sized American community hospital in, say, 1992. You would need to convince the Pharmacy and Therapeutics Committee. You would need physicians to accept that a practice they had been trained in, that they had been performing without evident harm, or at least without harm that had been attributed to the practice, required modification. You would need to select an alternative and establish dosing equivalencies. You would need to update the order sets that nurses and residents use. You would need to educate staff about the change and the reasons for it. You would need to manage the concerns of surgeons who had their own preferred protocols and did not particularly welcome interference from pharmacy. This is not an afternoon's work. In a resource-constrained institution with competing priorities, it can easily become nobody's work. The standard of care is a phrase that sounds neutral and scientific. What it actually describes is a social phenomenon as much as a clinical one. The standard of care is what most physicians in a given specialty, in a given era, in a given geographic and institutional context, do for a given problem. It is shaped by training, by institutional practice, by peer behaviour, and by the accumulated momentum of what has always been done. It is also, critically, a legal concept. A physician who follows the standard of care is generally protected, while a physician who deviates from it, even in a direction the evidence supports, carries additional liability. This creates a conservative pressure that operates entirely independently of the science. Demerol was the standard of care. staying with Demerol was, in a very specific and practical sense, the safer professional choice, not for the patient, but for the physician. That asymmetry held for decades. The 1980s brought a genuinely promising development in pain management, patient-controlled analgesia, or PCA, which allowed hospitalized patients to self-administer small bolus doses of opioid pain medication through a pump program to prevent overdose. It was a more humane system, it gave patients autonomy, and it was well suited to post-surgical recovery. It was also, in many hospitals, loaded with Demerol. The combination of self-administered dosing and meperidine's accumulating metabolite meant that patients who were using their PCA pumps regularly over multiple days were quietly building up normeperidine in their systems, sometimes experiencing agitation or confusion that was chalked up to the surgery, the anesthesia, the stress of hospitalization, or simply being a difficult patient. Patient-controlled analgesia was a genuine clinical innovation rooted in good principles. The old model of post-surgical pain management was nurse-administered intramuscular injections given on a fixed schedule, every 3 to 4 hours, on the clock, whether the patient was in agony or not, and with the full delays of the injection to bloodstream pathway. Pain peaked and troughed unpredictably. Patients waited in discomfort for doses that arrived on hospital time rather than human time. PCA changed this by putting a button in the patient's hand. Press the button, receive a small dose, wait the mandated lockout interval, press again if needed. The pump's programming ensured that the patient could not self-administer more than a safe amount over any given time window. The logic was sound. The limitation was that the logic applied to the delivery system, not to the drug being delivered. Loading a PCA pump with meperidine addressed the dosing frequency problem while leaving the metabolite problem completely intact. A patient recovering from abdominal surgery, using their PCA pump conscientiously over 3 or 4 days, was receiving repeated meperidine doses at patient-determined intervals, which, for a patient in real post-surgical pain, meant fairly frequent doses, and their normeperidine level was climbing accordingly. What this looked like clinically was sometimes subtle and sometimes not. A patient who becomes increasingly anxious and restless on day 2 of post-surgical recovery is not presenting a clear picture. A patient who develops fine tremors in the hands on day 3 has a long differential diagnosis: electrolyte abnormalities, residual anesthetic effects, anxiety, pain itself, and Demerol toxicity is unlikely to be at the top of the list unless the admitting physician is specifically thinking about it. A patient who has a seizure on day 4 is, by that point, in a situation that has escalated to the point where the immediate clinical management crowds out the root cause investigation. The PCA era also produced something that the earlier, nurse-administered era had partially concealed: reliable data on how much meperidine patients were actually consuming. When a nurse gives an injection every 3 to 4 hours, there is a record, but it is distributed across shift notes and medication administration records in ways that do not easily aggregate. A PCA pump logs every button press, every dose delivered, every lockout. This data, when it began to be analysed systematically in the late 1980s and early 1990s, painted a picture of meperidine consumption patterns that were, in some patients, considerably higher than anyone had been carefully tracking before. The normeperidine implications were not immediately acted upon, but the data was there, accumulating in pump memory and hospital records, waiting for someone to ask the right question. For patients with sickle cell disease, pain crises are not occasional inconveniences. They are severe, acute, recurring episodes of agony that bring people to emergency departments repeatedly, sometimes many times per year, sometimes many times per month. For decades, the standard treatment for sickle cell pain crises in American emergency rooms was Demerol, often in high doses, often in patients who'd been receiving it for years. These were precisely the conditions under which normeperidine toxicity was most likely to develop. Repeated dosing, high cumulative doses, and patients whose kidney function was sometimes compromised by the disease itself. The seizures that resulted were not always connected to the drug. They were attributed to the disease, to stress, to the unknowable complexity of sickle cell pathophysiology. The drug kept being given. Sickle cell disease is caused by a mutation in the gene encoding hemoglobin, the protein that red blood cells use to carry oxygen. The mutated hemoglobin distorts the shape of red blood cells under certain conditions: low oxygen, dehydration, cold, infection, causing them to assume a rigid crescent shape that clogs small blood vessels, restricts blood flow, and causes the intense diffuse pain of a vaso-occlusive crisis. This pain is real, severe, and often undertreated, a fact that has been documented extensively and attributed by researchers and patient advocates to a combination of factors that include inadequate pharmacological knowledge and the demographics of the disease. Sickle cell affects Black Americans disproportionately, and there is a substantial body of evidence that Black patients' pain has historically been undertreated in American emergency medicine. The irony is precise and uncomfortable. In a patient population that was already vulnerable to undertreated pain, the treatment that was being provided, Demerol, was one that compounded vulnerability with toxicity. Patients who had been coming to emergency departments for years, receiving meperidine during each crisis, were accumulating normeperidine over the course of multiple visits. The drug was not clearing completely between episodes in all patients. The threshold for neurotoxicity was being approached, sometimes crossed, in people who were already dealing with a chronic illness whose neurological complications, including stroke could obscure the drug's contributions. The seizures that some sickle cell patients experienced were genuine medical emergencies, and they were treated as such, but the treatment focused on the seizure rather than the cause. Anti-epileptic medications were administered, neurological consultations were obtained, imaging was reviewed, and the meperidine, having triggered the event, was sometimes continued because the pain that brought the patient in had not resolved. There are documented cases in the medical literature of patients experiencing meperidine-induced seizures who then continued receiving meperidine because the clinical team managing the seizure and the clinical team managing the pain were not effectively communicating with each other about what had caused the neurological event. This is not a story about malicious neglect. It is a story about how medical care is organized and how that organization, under real conditions, with real staffing and real time pressures and real informational silos, can produce outcomes that look, from the outside, like they should have been preventable. The patients kept coming, the Demerol kept being given, the normeperidine kept accumulating, and in the background, a literature was growing that made the connection clearly, waiting to be translated into practice change. Somewhere in the 1970s and 80s, as palliative care began to emerge as a legitimate medical discipline, with its own principles and its own advocates, a quiet conversation began about what drugs were actually appropriate for cancer pain. Morphine, long avoided in American medicine out of an exaggerated and sometimes racially inflected fear of addiction, was being re-examined. The World Health Organization's Pain Ladder, published in 1986, placed morphine at the top as the gold standard for severe cancer pain. Demerol was conspicuously not on the ladder, and not by accident. Pain specialists who had been watching normeperidine accumulation in cancer patients on continuous Demerol had seen enough, and the guidance was unusually direct. Do not use meperidine for chronic pain. The rest of medicine took a while to catch up. The emergence of palliative care as a formal medical discipline is, in the larger story of how medicine relates to human suffering, a genuinely important development. For most of the 20th century, dying in American hospitals meant dying in an environment optimized for cure, staffed by professionals trained primarily to fight disease, rather than to manage its end stages with grace and effectiveness. Pain in dying patients was often undertreated, partly out of fear of addiction, which is, in a terminal patient, a concern of such limited relevance that its persistence in clinical reasoning requires some explanation, and partly because the available tools were considered risky in ways that reflected the pharmacological mythology of the era rather than clinical evidence. Cicely Saunders, the British physician and nurse who founded the modern hospice movement, was among the first to argue systematically that morphine, given in appropriate doses and at appropriate intervals, was not only safe for dying patients but essential to humane care. Her work, and the work of others building the emerging field of pain medicine, began to shift the conversation. The question was not whether opioids were dangerous, of course they were. All powerful drugs are dangerous, but whether the dangers of undertreated pain were being weighed honestly against the dangers of treatment. Against this backdrop, meperidine's specific limitations became increasingly visible. Cancer patients often require opioids continuously, at scheduled intervals for extended periods, weeks, months, sometimes longer. This is precisely the dosing pattern under which normeperidine accumulation is most reliably produced. Patients on continuous meperidine for cancer pain were developing tremors, dysphoria, agitation, and, in some cases, seizures at a rate that pain specialists found impossible to attribute to anything other than the drug. The clinical observations were reinforced by pharmacokinetic measurements, showing normeperidine levels rising to concerning concentrations in patients on chronic therapy. The WHO Pain Ladder's exclusion of meperidine was not incidental. It reflected a considered judgment by an international expert group that whatever advantages meperidine offered in acute single-dose scenarios, it was entirely unsuitable for the sustained analgesia required in cancer and palliative care settings. This was, by the standards of international health guidance, a relatively clear message. It reached the specialists who were already thinking about the problem. Getting it from the palliative care literature into emergency medicine, post-surgical care and obstetrics would take considerably longer. Healthcare provider substance abuse is one of medicine's most carefully managed silences, discussed in hushed tones, handled through back channels, and statistically significant enough to have generated entire professional bodies, treatment programs, and licensing board protocols. Demerol holds a particular place in this history. It was for decades one of the most commonly diverted opioids in hospital settings, in part because it was everywhere, in part because its rapid onset made it appealing to people seeking relief from the specific kind of stress that comes with working in high-stakes environments for long hours, and in part because the culture of medicine had not yet developed adequate language for talking about impairment among the people doing the healing. The stories are numerous, the pattern is consistent, and the drug kept flowing. Physicians, nurses, pharmacists, and other healthcare workers have access to controlled substances that the rest of the population must obtain through considerably more complicated channels. This access is necessary. You cannot run a hospital without the ability to quickly administer powerful medications, and it is carefully regulated in theory, with logging requirements, dispensing controls, and audit trails designed to detect diversion. In practice, the effectiveness of these controls has varied considerably, and the culture of healthcare has, for most of the 20th century, been deeply reluctant to acknowledge impairment among providers. The reasons for this reluctance are understandable, even if the consequences are not acceptable. Healthcare is a culture built around competence, resilience, and the suppression of personal vulnerability in service of patient care. Admitting that you are struggling is, in this culture, not merely difficult, it is professionally dangerous. A physician who acknowledges a substance use problem faces licensing scrutiny, peer judgment, potential career consequences, and the social cost of having broken the implicit contract of professional invulnerability. The systems for managing impaired providers existed primarily to protect patients from ongoing harm, not to provide early, compassionate intervention for providers in the early stages of dependency. Demerol entered this culture as an ideal drug for misuse precisely because of the same properties that made it clinically popular. It was fast. It was available in every clinical area of the hospital. It was injectable, which meant the onset of effect was almost immediate. It was familiar, which meant its packaging, labelling and handling were unremarkable to anyone watching. And it carried, in the minds of the people who worked with it every day, some residual coating of the legitimacy it had been given by decades of clinical endorsement. This was not heroin. This was a pharmaceutical. This was something administered to patients every day by competent professionals. The mental accounting that goes into dependency rarely focuses on the pharmacological distinction between legitimate and illegitimate use, and meperidine was structurally easier to rationalize than almost any other opioid a healthcare worker might encounter. The diversion problem also fed back into the availability problem. If a drug is being widely used, it must be widely stocked. If it must be widely stocked, it is widely accessible. If it is widely accessible, the opportunities for diversion are numerous. The logistics of meperidine availability in hospitals, stocked on virtually every unit, available in multiple formulations, ordered under a wide range of clinical indications, created an environment in which the drug was genuinely difficult to contain, even in institutions with serious intent to do so. The combination of ubiquity, rapid onset, and cultural reluctance to investigate unusual patterns of consumption made Demerol a particular presence in the story of healthcare provider impairment that lasted until the formulary removals of the 2000s finally began to reduce its availability. In the early 1980s, a cluster of young drug users on the west coast of the United States developed sudden, severe Parkinson's disease. They had been using a synthetic heroin analogue that had been contaminated with a compound called MPTP, which destroys the dopamine-producing neurons in the substantia nigra with alarming efficiency. This is not directly a Demerol story, but it is a meperidine-adjacent one, because the contaminated compound was a meperidine analogue, synthesized by someone attempting to make a pethidine-type drug on the cheap, and creating something catastrophically more dangerous in the process. The cluster, once identified, led to an explosion of Parkinson's research that continues to this day. The lesson, which medicine has been slow to generalize, is that the metabolic territory around opioid synthesis is littered with hazards that do not always announce themselves. The synthesizer in question was a young graduate chemistry student in California named Barry Kidston, who in the late 1970s began producing his own meperidine analogues in a home laboratory. The specific compound he was attempting to make was MPPP, a meperidine derivative with opioid activity. The synthesis of MPPP is chemically demanding, and Kidston, cutting corners, produced a batch contaminated with MPTP, 1-methyl-4-phenyl-1,2,3,6-tetrahydropyridine, a compound that is almost harmless in itself but is converted in the brain by a naturally occurring enzyme called monoamine oxidase B into the toxic compound MPP+. MPP+ is exquisitely selective in its toxicity. It is taken up specifically by dopaminergic neurons in the substantia nigra, the region of the brain whose degeneration produces Parkinson's disease, and it destroys them with a speed that no natural disease process matches. Kidston developed severe Parkinsonism within days of exposure. The case was documented, published, and filed away until several years later, when a small cluster of similar cases appeared in California, all young people who had purchased street drugs and all presenting with symptoms of advanced Parkinson's disease. The neurologists who identified this cluster, J. William Langston among them, recognized that they were looking at a pharmacologically induced Parkinsonian syndrome and traced it to a batch of contaminated synthetic opioids circulating in Northern California. The MPTP connection was established, the mechanism was worked out, and the discovery was immediately recognized as important, not just as a public health event, but as a scientific tool. If you could reliably produce Parkinson's disease in animals by administering MPTP, you had an animal model for a disease that had previously lacked one, and the research that followed contributed substantially to the understanding of dopaminergic neurodegeneration. The connection to meperidine is structural and historical rather than causal. Demerol itself does not contain MPTP and does not produce it during metabolism. But the disaster illustrated something important about the pharmacological neighbourhood in which meperidine sat. The territory of piperidine-based synthetic opioids was one in which small synthetic errors could produce catastrophically different biological effects. The lesson that the chemical space around opioid analogues was capable of hiding neurological hazards that were not visible until they had already done their damage was one that the field absorbed in the context of MPTP research and did not consistently apply to the investigation of meperidine's own metabolic products. There is a recurring dynamic in the history of pharmaceutical harms, where the people who notice the problem earliest are not the researchers, not the regulators, and not the physicians writing the orders. They are the nurses administering the medication, watching the patient, and documenting the changes. In the case of Demerol, nursing literature was raising concerns about normeperidine toxicity, about seizure risk in patients receiving repeated doses, and about the mismatch between what the drug was supposed to do and what it was actually doing years before institutional formulary decisions began to shift. This is a pattern that recurs throughout the history of drug safety, and it says something important about whose observations medicine has historically been built to take seriously. Nursing practice is, in the context of medication safety, a form of continuous surveillance. Nurses are at the bedside, they administer the drugs and they observe the patient before, during, and after administration. They are the first to notice when a patient who was alert this morning is confused this afternoon. They are the first to document the tremor in the hands, the restlessness that seems disproportionate to the level of pain, the myoclonus that appears after 2 days on a PCA pump. They chart these observations, they report them, and in a well-functioning system, those observations feed into clinical decision-making. In a less than well-functioning system, they accumulate in nursing notes that nobody systematically reviews. The nursing literature on meperidine toxicity is a quiet, persistent thread that runs through clinical journals from the 1970s onward. Case reports authored by nurses or co-authored with nurses, continuing education articles discussing normeperidine accumulation and its clinical signs. Practice guidelines developed by nursing professional organizations that included specific warnings about extended meperidine use. These documents existed. They were read by nurses who were invested in the question. They were less consistently read by the physicians who wrote the orders. This is not an accusation. It is a structural observation. The medical information environment is organized around physician authorship and physician readership in ways that have historically meant that nursing literature, however well grounded in clinical observation, travelled in a parallel channel that intersected with physician practice only at specific points. A nurse who had read a continuing education article about normeperidine toxicity and was concerned about a patient's tremors on day 3 of post-surgical Demerol needed, in order to act on that knowledge, a physician who was willing to receive the information, integrate it, and change the order. The nurse's observation was only as powerful as the communication system that allowed it to reach decision-making authority. The advocacy that eventually produced formulary change drew on nursing observations as a key part of its evidentiary base, precisely because nurses had been watching and documenting the problem longer than anyone else. The ISMP, which became the institutional voice for meperidine's removal, was an organisation with deep roots in nursing and pharmacy practice. Its reports on meperidine-related harm were built in significant part on adverse event reports submitted by nurses who had been noting concerning patterns for years. By the time the medical establishment was ready to hear the argument, nursing had been making it for a generation. The Food and Drug Administration's relationship with Demerol over the decades is not a story of corruption or deliberate negligence. It is a story of something more ordinary and in some ways more troubling. The difficulty of acting on safety signals for a drug that is already embedded in medical practice, that has a very large installed base of prescribers and institutional users, and whose risks are not expressed in simple, visible, attributable harms, but in diffuse, delayed, and easily misattributed neurological events. Seizures in hospitalized patients are not unusual. Agitation and confusion are not unusual. Tremors in elderly patients are not unusual. Connecting these events to a specific drug when many other variables are present requires exactly the kind of systematic pharmacovigilance that American drug regulation was, for most of the 20th century, not strongly built to perform. The FDA's primary tool for post-market drug safety is the Adverse Event Reporting System, known for most of its history as MedWatch, which collects voluntary reports from healthcare providers, patients, and manufacturers about adverse events observed in connection with approved drugs. The system is voluntary, which means it depends on people recognizing that an adverse event has occurred, attributing it correctly to a specific drug, taking the time to file a report, and the FDA having the analytical resources to detect patterns in the incoming data. Each of these steps has historically been leaky. Recognition is the first problem. A physician treating a hospitalized patient who has a seizure on day 4 of post-surgical care is managing an acute emergency. The immediate goal is to stop the seizure and stabilize the patient. Investigating whether the seizure was caused by a medication the patient has been receiving is important, but it competes with a long list of other immediate clinical priorities. In many cases, it simply does not happen in the acute phase, and by the time the crisis is resolved, the discharge planning is underway, and the attribution of causality to meperidine requires the kind of deliberate retrospective analysis that nobody has time to perform. Many such events were simply never reported to anyone with authority over the drug's labeling. Attribution is the second problem. Even when an adverse event was recognized as potentially drug-related, connecting it specifically to normeperidine accumulation required pharmacological knowledge that was not uniformly distributed among practicing clinicians. A nurse or physician who had encountered this connection in the literature would recognize the pattern. One who had not would see a patient with a new neurological finding and attribute it to a long list of possible causes. The meperidine connection, while documented in the literature, was not prominently featured in the drug's prescribing information for most of its commercial life. It was knowledge for specialists, not general clinical practice. The FDA's ability to detect patterns in underreported, diffusely distributed adverse events improved over the decades, but the improvements were incremental and never fully solved the fundamental problem. Voluntary reporting systematically undercounts events, and diffuse neurological events in hospitalized patients are particularly likely to fall through the cracks. What eventually drove change was not regulatory action based on FDA surveillance, but institutional and professional action driven by organizations like the ISMP, which were closer to the clinical ground and more attentive to the specific pharmacological mechanisms at issue. By the early 2000s, the Institute for Safe Medication Practices, a non-profit organization that functions as something like the conscience of hospital pharmacy, had seen enough. They place meperidine on their list of high-alert medications, drugs that bear a heightened risk of causing significant patient harm when used in error, and began a sustained evidence-based campaign to get it off hospital formularies entirely. Their argument was methodical and, by that point, essentially unanswerable. The drug has a toxic metabolite that accumulates with repeated dosing. There are better alternatives for every clinical indication in which it is used, and the only reason it remains in practice is institutional inertia. It was the kind of argument that should have been made 20 years earlier. It was also, slowly, heard. The ISMP occupies a specific and somewhat unusual position in the American healthcare ecosystem. It is not a regulatory body. It cannot compel hospitals to do anything. It has no enforcement authority over prescribing practices, formulary decisions, or clinical protocols. What it has is credibility, built over decades of careful, evidence-based work on medication safety, and a distribution network that reaches the pharmacists and medication safety officers who are, in most hospitals, the people with both the motivation and the institutional access to push for formulary change. The ISMP speaks to an audience that is already predisposed to listen and already positioned to act. Their meperidine campaign began with documentation. The ISMP collects adverse event reports through its own reporting network, which operates independently of the FDA's system and has, in certain respects, better signal sensitivity for the kinds of events that drug-drug interactions and toxic metabolite accumulation produce. Their meperidine data showed a pattern that, reviewed in aggregate, was difficult to explain as coincidence. Patients on repeated meperidine doses who developed neurological events, tremors, myoclonus, seizures, at a rate inconsistent with their underlying conditions. The pattern was consistent with normeperidine accumulation and inconsistent with most other plausible explanations. The ISMP's publications are read carefully by pharmacy directors and medication safety officers across American hospitals. When the ISMP says a drug should come off the formulary, those professionals take the recommendation seriously, not because they're told to, but because the organization has earned its authority through the quality of its work. The meperidine recommendation triggered formulary review processes at a significant number of institutions in the mid-2000s, and at many of those institutions, the review concluded in the direction the ISMP had argued for. What is worth noticing about this process is how late it was and how long it took even after it began. The pharmacological knowledge that underlied the ISMP's argument had existed in the literature for decades. The adverse event data that gave it practical urgency had been accumulating in nursing charts and medication administration records throughout the post-war period. What was required to translate that knowledge into institutional action was not new science. It was an organization willing to make the argument clearly, persistently, and to an audience positioned to act on it. That organization existed. It simply had not focused its attention on meperidine with sufficient sustained intensity until the early 2000s, which means that the decades between the problem's recognition and its partial resolution are, in the most direct sense, a product of organizational priorities and institutional attention. The removal of Demerol from obstetric practice was not a single moment but a long, quiet withdrawal. Hospitals began reviewing their labour and delivery protocols, driven partly by ISMP guidance, partly by the growing literature on normeperidine toxicity, and partly by the advocacy of midwives, doulas, and maternal health practitioners who had been arguing for better alternatives for decades. Epidural analgesia, which had existed as an option since the 1970s, became increasingly preferred. Fentanyl replaced meperidine in many IV protocols. The argument that Demerol was better for labouring women because it was less likely to cause respiratory depression in the newborn. An argument that had never been well supported, was quietly retired, and the generations of women who had delivered their children in a fog of meperidine were simply not discussed. The epidural's rise is, in the story of Demerol's exit from Obstetrics, the single most important development. Epidural analgesia, the placement of a catheter in the epidural space of the spine, and the continuous infusion of local anesthetic, with or without a low-dose opioid, provides labour pain relief that is, in most cases, dramatically more effective than systemic meperidine, while producing far less fetal exposure. The local anesthetic does most of the work. It does not cross the placenta in clinically significant amounts at the doses used epidurally. The fetus is essentially protected from the drug's effects in a way that systemic meperidine, which crosses the placenta efficiently and reaches the fetal circulation within minutes of administration, never was. The epidural's adoption was not smooth or uniform. There were, and continue to be, legitimate clinical debates about its effects on labour progress, about its association with maternal fever, and about the appropriate timing of its administration. There are women for whom epidural analgesia is contraindicated or unavailable. There are birth philosophies, represented by midwifery models of care and the natural birth movement, that have argued against routine pharmacological intervention in labour for reasons that go beyond the specifics of any individual drug. These are real considerations, and they have shaped how labour pain management has evolved. But in the institutional context of American hospital obstetrics, the epidural effectively solved the problem that meperidine had been used to address, solved it better by most measurable criteria, and did so without the fetal respiratory depression that had been a known and documented consequence of systemic opioid use in labour for decades. The transition was gradual because the epidural required anesthesiologist availability, which was not uniformly achievable in all hospitals and all settings, and because protocols take time to change. But by the 1990s and 2000s, in hospitals with full anaesthesia coverage, systemic meperidine in labour was becoming a second-line option rather than a default, and in many institutions it was becoming an option rarely chosen at all. The women whose labours had been managed with Demerol over the previous 4 decades were not, in any systematic way, sought out, informed of what they had received, or given the opportunity to participate in a retrospective conversation about what the drug had done to their experience. This is not unusual in the history of medical practice change. Practices are retired. The people who received them while they were current are not generally the focus of institutional attention after the fact. The children born under meperidine's influence, whose first minutes of extrauterine life were shaped by the drug's sedative effects on their respiratory systems, grew up without this as a labelled part of their birth narrative. It was simply what happened when you were born in the 1960s. It was medicine. It was the standard of care. Even as Demerol disappeared from labour and delivery, from oncology, and from patient-controlled analgesia protocols, it hung on in emergency departments with a persistence that puzzled reformers. The reasons were cultural as much as clinical. Emergency medicine had developed its own pharmacological traditions, its own handed-down protocols, and its own relationship with Demerol that was partly habit and partly a specific set of clinical beliefs. That meperidine was particularly effective for biliary colic, for renal colic, for migraines, many of which turned out, under systematic study, not to be supported by the evidence. The biliary colic claim in particular rested on the idea that meperidine caused less spasm of the sphincter of Oddi than morphine, a belief that had been circulating in medical education for decades without ever being confirmed in clinical trials. Emergency medicine is a specialty that runs on protocols, pattern recognition, and the institutional memory of residency training. An emergency physician who trained in the 1980s learned specific drugs for specific indications, and those associations embedded during the high-pressure, high-volume environment of residency, are not easily overwritten by subsequent literature. Demerol for migraines, Demerol for renal colic, Demerol for biliary colic. These were not arbitrary choices. They reflected the clinical teaching of an era, but they had the quality of received wisdom rather than evidence-based selection, and received wisdom in medicine is particularly resistant to revision because it comes packaged with the authority of one's teachers. The sphincter of Oddi claim deserves particular attention because it illustrates how a pharmacological belief can persist across decades of clinical practice without anyone doing the fairly straightforward study that would either confirm or refute it. The sphincter of Oddi is the muscular valve that controls the flow of bile and pancreatic juice into the small intestine. In patients with biliary colic, spasm of this sphincter can worsen pain. Morphine, at standard doses, causes some degree of sphincter of Oddi spasm. The theoretical argument for meperidine was that it caused less spasm, making it a better choice for biliary pain. This theoretical argument was repeated in medical education for approximately 4 decades. It appeared in textbooks. It was taught in rounds. It was the rationale given to medical students who asked why Demerol was being used instead of morphine. And when it was finally subjected to proper clinical evaluation, randomized controlled trials comparing meperidine and morphine for biliary colic, measuring pain outcomes, adverse events, and spasm-related effects, the evidence did not support the preference. Morphine and meperidine performed similarly for biliary pain. The theoretical advantage of meperidine was not confirmed in clinical practice. The belief outlasted the evidence for it by a considerable margin. Migraines presented a similar pattern. The use of meperidine for acute migraine in emergency settings was widespread, culturally embedded, and resistant to change despite an evidence base that clearly favoured other agents. Dopamine antagonists, non-steroidal anti-inflammatory drugs, triptans, for most patients. The meperidine for migraine practice had an additional complication. Headache specialists had been arguing for years that opioid use in migraine patients was associated with medication, overuse headache and chronic migraine progression, a concern that applied to all opioids, but was particularly pointed in the context of meperidine's specific adverse effect profile. The emergency department, for much of the 1990s and 2000s, remained a place where patients with severe migraine could reliably receive Demerol, reinforcing patterns of use that headache medicine was simultaneously trying to discourage. There is a chapter of the Demerol story that emerged fully only as psychiatric medication use increased in the latter half of the 20th century, and it involves a potentially fatal drug interaction that was not prominently featured in Demerol's prescribing information for most of its commercial life. Meperidine inhibits serotonin reuptake. In patients taking monoamine oxidase inhibitors, which were among the first antidepressants and remained in use for decades, combining them with meperidine could trigger serotonin syndrome, a life-threatening state of hypothermia, agitation, neuromuscular instability, and cardiovascular instability that could kill within hours. The contraindication existed in the literature. Whether it was reliably communicated to prescribers and whether prescribers reliably checked for it before ordering the drug is a different and considerably more uncomfortable question. Serotonin syndrome results from an excess of serotonergic activity in the nervous system. Serotonin is a neurotransmitter involved in mood, cognition, and autonomic function, and its normal operation depends on precise regulation of release, receptor binding, and reuptake. Monoamine oxidase inhibitors work by blocking the enzyme that breaks down serotonin, dopamine, and norepinephrine, increasing the amount of these neurotransmitters available in the synapse. They were the first generation of antidepressants, developed in the 1950s and used widely through the 1960s, 70s, and beyond. When a patient taking a MAO inhibitor receives a drug that also increases serotonergic tone, by blocking reuptake, as meperidine does, the cumulative effect can be catastrophic. The clinical presentation of serotonin syndrome is distinctive and terrifying. A patient who has received a meperidine while on a MAO inhibitor may begin, within minutes to hours, showing signs of agitation, confusion, rapid heart rate, high blood pressure, fever, tremor, and the characteristic neuromuscular findings of clonus, rhythmic involuntary muscle contractions, and hyperreflexia. In severe cases, the temperature can rise to dangerous levels, the muscles can break down in a process called rhabdomyolysis, the kidneys can fail, and death can follow. The speed of onset and the severity of the syndrome make it a genuine medical emergency. The contraindication between meperidine and MAO inhibitors was documented in the 1960s, once the MAO inhibitor class was well established and cases of the interaction had been observed. It appeared in package inserts, it appeared in drug interaction databases, it appeared in pharmacology textbooks, and it was violated in clinical practice with a regularity that suggests it was not consistently communicated or consistently checked. Patients who presented to emergency departments in pain, in whom the MAO inhibitor was not identified from an incomplete medication history, received meperidine and sometimes developed serotonin syndrome. The medication history problem is not trivial. Patients in acute pain are often not the most reliable historians of their complete medication list, and emergency providers often do not have access to an accurate list at the time of prescribing. The expansion of antidepressant prescribing in the 1980s and 90s, with the introduction of selective serotonin reuptake inhibitors, added a new dimension to this concern. SSRIs are not MAO inhibitors, and the severity of their interaction with meperidine is considerably less than the MAO inhibitor interaction, but the same pharmacological mechanism, serotonin reuptake inhibition by meperidine stacking, on top of serotonin reuptake inhibition by the antidepressant, created at least a theoretical risk of serotonergic excess that became increasingly clinically relevant as SSRI prescriptions became common enough that a meaningful percentage of patients presenting to emergency departments or admitted for surgery were taking one. Meperidine was not just a drug with a toxic metabolite. It was a drug with a drug interaction profile that became more dangerous as the pharmacological landscape around it changed. Demerol never achieved the cultural infamy of heroin or the street-level ubiquity of oxycodone, but it occupied its own specific niche in the pharmacology of recreational opioid use that is worth understanding in the context of its overall story. Its rapid onset, faster than morphine when given intravenously, made it appealing to people seeking an immediate effect, and its wide availability in hospital settings made it a frequent target for diversion. The culture that developed around diverted Demerol, particularly in the 1970s and 1980s, was driven partly by its availability and partly by a specific set of beliefs about its effects that mirrored, in miniature, the same marketing mythology that had shaped its clinical adoption. The idea that this was a cleaner, smoother, more modern opioid experience, which is exactly the kind of claim that tends not to survive extended acquaintance with normeperidine. The pharmacology behind the subjective appeal of meperidine is real, not invented. The rapid onset of intravenous meperidine produces distinctive quality of effect that experienced opioid users described in consistent terms across multiple decades and multiple contexts. A fast, clean rush, less nauseating than heroin, more focused than morphine, with an almost stimulant-adjacent edge in the early phase that the pharmacologically informed observer recognizes as early normeperidine activity. It felt to the people describing it like the better version of what other opioids did. This is the same claim that was made in the medical literature in different language. The drug produced this impression reliably enough that it was repeated in both clinical and street contexts. The early normeperidine stimulant effect deserves attention here because it illustrates something important about how drug abuse liability is assessed. When pharmacologists evaluate a drug's potential for misuse, They look in part at its reinforcing effects. Does it produce an experience that motivates repeated use? The initial phase of meperidine exposure, particularly by injection, includes a phase of CNS stimulation driven by low-level normeperidine accumulation before toxicity develops. This stimulant-like quality in the context of opioid-induced analgesia and euphoria may have enhanced the drug's reinforcing properties in ways that were not fully appreciated during the era of its initial clinical evaluation, because the tools and frameworks for understanding drug abuse liability were considerably less developed in 1945 than they are today. Diversion from hospital settings followed the pattern typical of pharmaceutical drug misuse in the mid-20th century: theft by healthcare workers, forgery of prescriptions, and the diversion of legitimately obtained prescriptions into markets that sold them at markup. Meperidine's specific advantages for diversion, ubiquity in hospital settings, injectable formulation, hyperdose value to users, made it a recurring target. The consequences of this diversion were the same consequences as the consequences of legitimate clinical use, scaled to patterns of use that were, by definition, not subject to any clinical oversight. The normeperidine problem did not disappear in street contexts. It simply arrived without anyone present who knew what to do about it. The most visible face Demerol ever had in popular culture was not a pharmaceutical advertisement or a clinical guideline. It was Michael Jackson, who by the late 1980s and throughout the 1990s was using meperidine in quantities and with a frequency that constituted, by any reasonable clinical measure, a significant opioid dependency. His use was facilitated by physicians operating under conditions that blurred the line between medical treatment and accommodation of a celebrity's preferences, and it took place against a backdrop of genuine physical pain. The scalp burns he suffered during a Pepsi commercial filming in 1984 had required surgeries and left him with a chronic pain condition, alongside the particular vulnerability that attaches to fame, isolation, and the medical profession's historic discomfort with denying powerful people what they want. The Demerol chapter of Jackson's life was not the only chapter of his pharmaceutical story, but it was an early and instructive one. The Pepsi incident occurred in January of 1984 during the filming of a commercial for which Jackson was performing a dance routine involving pyrotechnic effects. A pyrotechnics malfunction ignited his hair, causing second-degree burns to his scalp. The injuries required multiple surgeries, and the pain associated with both the burns and the surgical procedures was genuine and severe. The prescribing of opioid analgesics in this context was medically appropriate. What followed was the familiar progression from appropriate acute treatment to a pattern of use that persisted and escalated beyond what any acute injury would justify. A progression that has been documented in enough people that medicine has a name for it, and that has particular dynamics in contexts where the patient has unusual access to physicians willing to continue prescribing. Jackson's entourage included physicians whose relationship with their patient was complicated by the specific distortions of celebrity medicine. The physician who treats a famous, powerful, wealthy person in distress operates under pressures that the physician in a standard clinical setting does not face. The patient's preferences carry unusual weight, the threat of replacement is always present, and the cultural dynamics of celebrity create a context in which saying no to a patient's request for medication requires a kind of professional courage that is not evenly distributed. This is not an excuse. It is a description of a failure mode in medical practice that is well documented and has caused significant harm in numerous cases beyond Jackson's. Jackson himself spoke publicly about his Demerol dependence in the early 1990s, describing it as something that had developed in the context of treatments for the scalp burns and subsequent scalp reconstruction surgeries. He sought treatment and, by his public account, achieved a period of sobriety. the dependency returned. By the time of his death in 2009, the dominant pharmaceutical in his story was propofol, a general anesthetic being used for sleep induction, and the Demerol chapter had been superseded in public attention. But the arc of his relationship with meperidine, genuine pain, appropriate initial treatment, escalating use facilitated by physicians with compromised professional boundaries, is a compressed and unusually visible version of a trajectory that was playing out, less visibly, in countless other settings across the same decades. If you were designing a population of patients to be maximally vulnerable to normeperidine toxicity, you would design something that looks a great deal like the average resident of a skilled nursing facility in 1990. Elderly patients have reduced kidney clearance, which slows the elimination of normeperidine. They have baseline cognitive vulnerabilities that make neurological side effects harder to detect and easier to attribute to dementia or delirium of other causes. They are often on multiple medications, increasing the risk of drug interactions. They are frequently in pain, making opioid use common, and they are often unable to reliably report their own symptoms, which means the agitation, the tremors, the confusion that normeperidine produces can go on for considerable time before anyone connects the presentation to the medication. It is in retrospect a situation that should have prompted much earlier action. The pharmacokinetics of aging are, for almost every drug class, a story of reduced clearance and increased exposure. The kidneys and liver, which together handle the elimination of most drugs and drug metabolites, decline in function over the decades in ways that are partially predictable from age but also influenced by the cumulative effects of chronic illness, reduced blood flow, and the simple wear of biological systems. A 60-year-old with normal kidney function for their age clears normeperidine more slowly than a 30-year-old with the same nominal function. An 80-year-old with a mild chronic kidney disease that is essentially universal in that age group clears it more slowly still. The result is that doses of meperidine that would produce transient manageable effects in a younger person can produce sustained, clinically significant normeperidine accumulation in an older one. The skilled nursing facility environment in the 1980s and 90s was one in which pain management was a recognized problem that had not been fully solved. Residents with osteoarthritis, hip fractures, post-surgical pain, and cancer experienced significant pain that the facility's medical staff, often a small number of physicians or physician assistants managing large patient panels, addressed with whatever pharmaceutical tools were familiar and available. Meperidine was familiar and available. It appeared in standing order sets. It was stocked in medication carts. It was the answer that came to mind when a resident complained of pain and something injectable was needed. The cognitive effects that normeperidine accumulation produces, agitation, confusion, tremor, myoclonus, are, in an elderly population, among the most common symptoms attributed to dementia, urinary tract infections, medication side effects from other drugs, and simple deterioration. A nursing home resident who develops increased agitation on day 3 of post-fall meperidine treatment is not unusual. A resident with established dementia who becomes more confused is not unusual. The connection to meperidine requires that someone on the clinical team is thinking about it specifically, and in the staffing and workflow conditions of 1990s skilled nursing facilities, that specific connection was regularly missed. This is the kind of harm that does not make headlines. It is not dramatic. It is not clearly attributable. It is diffuse, accumulated over time, distributed across thousands of residents in thousands of facilities, manifesting as incremental worsening of outcomes that were already poor and that could be attributed to a dozen causes other than the drug. It is the kind of harm that a reactive pharmacovigilance system, one that waits for individual adverse event reports, is poorly designed to detect because each individual event is ambiguous. only the pattern is diagnostic, and detecting the pattern required a level of systematic analysis that was not being applied to meperidine in skilled nursing settings until well after the problem had been running for years. The story of Demerol in the United Kingdom, where it was marketed under the name pethidine, follows a broadly similar arc but with some instructive differences in timing and institutional response. The British National Formulary, the authoritative prescribing reference for UK clinicians, moved to restrict and then effectively discourage meperidine use earlier and more decisively than American institutional bodies. The National Institute for Health and Care Excellence issued guidance that was considerably more critical of meperidine in obstetric settings than anything produced by comparable American bodies at similar points in time. The reasons for this divergence are multiple and debated, but they touch on differences in how clinical guidelines are developed, how pharmaceutical marketing operates within different regulatory environments, and how the relationships between professional bodies and industry are structured. The British National Health Service, established in 1948, created an institutional context for pharmaceutical prescribing that differed from the American market in ways that were, in retrospect, partially protective. The NHS was, from its inception, a purchaser of drugs with an interest in cost-effectiveness, and with the institutional machinery to develop systematic guidance about what drugs to use and when. The British National Formulary, updated regularly and distributed to every prescribing clinician, provided a level of centralised, evidence-based prescribing guidance that had no direct equivalent in American medicine, where prescribing norms were set by specialty societies, individual training programs, hospital formularies, and pharmaceutical marketing in a more fragmented and market-influenced way. This is not to say that the British system handled pethidine perfectly. The drug was widely used in British obstetrics, available for administration by midwives without physician oversight, and the harms associated with its use in labour were documented in British literature with roughly the same timing as in American literature. The Confidential Inquiry into Maternal Deaths, a long-standing British audit of maternal mortality, included cases in which opioid-related respiratory complications contributed to maternal deaths over a period of decades. The harm was real on both sides of the Atlantic. The difference was in the speed and decisiveness of institutional response once the evidence had accumulated. The NICE guidance on intrapartum care, which addressed pain management in labour, took a considerably more sceptical view of systemic opioids, including pethidine, than the contemporaneous American guidance from organisations like the American College of Obstetricians and Gynecologists. British midwifery, which plays a more prominent role in normal labour management in the UK than its American counterpart, had developed a practice culture that was less reflexively reliant on systemic opioid analgesia and more oriented toward non-pharmacological pain management approaches. This cultural difference did not eliminate pethidine use, but it reduced its default status in a way that had no direct parallel in American obstetric practice. The comparison is not meant to idealise the British system, or to suggest that a different healthcare structure would have produced perfect outcomes with meperidine. It is meant to illustrate that the persistence of Demerol in American clinical practice was not simply a function of the pharmacological facts. It was also a function of institutional structures, professional cultures, and market dynamics that shaped how those facts were translated into practice. The same drug, the same evidence base, and different systems produced meaningfully different timelines of action. In the early 2000s, American hospitals began operating under increasing pressure from accreditation bodies, payers, and the nascent hospital quality movement to track adverse drug events, to measure and report medication errors, and to take systematic action when patterns of harm emerged. This was, in theory, exactly the kind of infrastructure that should have accelerated the removal of Demerol from hospital formularies. In practice, the results were mixed. Some institutions, particularly academic medical centres with robust pharmacy and therapeutics committees, moved quickly. Others moved slowly. The data that quality programs generated was real, and in many cases alarming. But data requires interpretation, and interpretation requires someone to act on it. And acting on it requires changing protocols that physicians had followed for their entire careers. The human factors dimensions of pharmaceutical reform turned out to be at least as challenging as the scientific ones. The Joint Commission on Accreditation of Healthcare Organizations, the dominant hospital accreditation body in the United States, had been moving toward quality metrics and outcomes reporting since the 1980s, and by the early 2000s it was explicitly requiring hospitals to maintain adverse event reporting systems and to demonstrate systematic responses to identified safety problems. The Centers for Medicare and Medicaid Services was developing its own quality reporting requirements, tied to reimbursement in ways that created financial incentives for hospitals to take safety seriously beyond the purely ethical motivation. Hospital quality officers, a professional role that barely existed in 1990 and was ubiquitous by 2005, were tasked with reviewing adverse event data, identifying patterns, and driving improvement initiatives. What quality programs revealed about meperidine varied by institution, but the pattern across institutions was consistent enough that the ISMP's aggregate picture was confirmed repeatedly at the local level. Hospitals that pulled their meperidine adverse event data and looked at it systematically found seizures, falls, excessive sedation, delirium, and neurological events in meperidine-treated patients at rates that were difficult to attribute to chance. The drug's footprint in the adverse event record was not subtle. Once someone was looking at the right data with the right question, the challenge was the last mile. A hospital quality officer who generated a report showing elevated adverse event rates associated with meperidine and brought it to the Pharmacy and Therapeutics Committee was initiating a process, not completing one. The P&T committee would review the data, acknowledge the concern, and begin discussing alternatives. The discussion would surface the objections. What about post-op shivering? What about our emergency department protocols? What do we do about the surgeons who have been ordering Demerol for 40 years? These were not bad faith objections. They were real clinical and operational questions, but they extended timelines and in some institutions indefinitely. Some hospitals acted decisively. Some hospitals generated reports, held discussions, formed subcommittees, and continued ordering Demerol for years while the subcommittee's work remained ongoing. The quality movement's contribution to meperidine's eventual decline was real but incremental. It created the infrastructure for systematic analysis that allowed the problem to be seen clearly at the institutional level, and it created accountability structures that made continued inaction more professionally uncomfortable than it had previously been. What it did not do, because quality programs are not designed to override clinical practice preferences, is force the change. That required the combination of quality data, ISMP advocacy, formulary committee processes, and the slow retirement of clinical generations trained on Demerol, all arriving in the same approximate window of time and producing collectively the shift that no single mechanism could produce alone. The practical question underneath all the pharmacology and institutional politics is a simple one. When hospitals decided Demerol needed to go, what did they put in its place? The answer is not a single drug, but a suite of alternatives tailored to the specific clinical situations in which meperidine had been used. Morphine, its reputation gradually rehabilitated by the evidence base for cancer pain management and palliative care, returned to prominence. Hydromorphone, faster acting and without the metabolite problem, became a preferred choice in many acute pain and post-surgical settings. Fentanyl, already dominant in anesthesia, expanded into procedural sedation and IV analgesia. None of these drugs are without risk. They're all opioids, with all that it implies, but none of them produce a seizure-causing metabolite that accumulates with repeated dosing. That is, as a bar to clear, not a high one. It is somewhat alarming that it took as long as it did. Morphine's rehabilitation as a mainstream analgesic, its return, in effect, to a status of first-line opioid, is a story that unfolds in parallel with the palliative care movement and with the gradual dismantling of the excessive addiction fears that had shaped American opioid prescribing since the Harrison Act. The evidence assembled by pain medicine specialists in the 1980s and 90s consistently showed that morphine, given in appropriate doses for genuine pain, produced addiction in a small minority of patients and was safe and effective in the majority. The catastrophizing around morphine use that had made meperidine's launch possible, the idea that any sustained morphine exposure was a dangerous step toward dependency, was progressively replaced by a more calibrated understanding that distinguished between physical dependence, which is a predictable physiological response to sustained opioid exposure, and the compulsive, harm-driven use pattern that constitutes addiction in the clinical sense. Hydromorphine emerged as the preferred alternative to meperidine in many settings, where rapid onset was required or where meperidine had been the standing order. It is approximately 5 times more potent than morphine, shorter acting, and does not produce a neurotoxic metabolite in clinically relevant quantities under standard dosing conditions. Its pharmacokinetic profile made it well suited to both IV and PCA use, and its potency, while requiring careful dose conversion from meperidine, was manageable with standard opioid prescribing training. Hospitals that made the switch from meperidine to hydromorphone in their post-surgical order sets did not, in general, observe an increase in adverse events, which was itself a data point. The drug it was replacing had been adding risk without adding benefit. Fentanyl's expansion into acute pain settings from its traditional home in anesthesia was driven by the same properties that made it valuable in the operating room: very rapid onset, short duration of action, high potency per milligram, and a relatively clean metabolic profile. For procedural sedation, short painful procedures performed in emergency departments or procedure suites, fentanyl became essentially standard. For IV analgesia in acute pain, it became the most commonly used opioid in many emergency departments during the 2010s, displacing both morphine and meperidine. Its own risks, respiratory depression with rapid administration, the escalating potency concerns that have dominated opioid news coverage in the fentanyl analog era, are real, but they are the risks of the opioid class rather than the specific risks of meperidine's toxic metabolite. If there is one clinical application that has allowed Demerol to survive its own retirement with something approaching dignity, it is this one. Meperidine is genuinely, demonstrably effective at stopping post-operative shivering. This is not a myth, not a marketing claim, and not a piece of clinical folklore that dissolves under scrutiny. The mechanism involves meperidine's activity at kappa opioid receptors and possibly at alpha-2 adrenergic receptors, and the effect is real enough that it remains listed in current clinical guidelines as a legitimate use case. The dose required is small, typically 25 milligrams given once, which means the normeperidine accumulation problem is largely irrelevant. It is genuine, narrow, evidence-supported application for a drug that failed everywhere else it was applied. As rehabilitations go, it is modest, but it is real. Post-operative shivering is one of those clinical phenomena that is simultaneously common, uncomfortable for patients, and poorly understood mechanistically. It occurs in somewhere between 20 and 60% of patients recovering from general anesthesia, depending on the procedure, the anesthetic agents used, the ambient temperature, and individual patient factors. The shivering is not simply a response to hypothermia, although hypothermia is a contributing factor in some cases. It also involves central thermoregulatory mechanisms that are disrupted by anesthetic agents, and that, in the recovery phase, generate a shivering response as the body attempts to restore normal temperature regulation. The standard non-pharmacological measures for postoperative shivering, warm blankets, forced air warming devices, warmed intravenous fluids, are effective at managing the hypothermia component, but do not reliably suppress the centrally mediated shivering. This is where meperidine enters. Its efficacy for postoperative shivering is mediated primarily through kappa opioid receptor activity, rather than the mu receptor activity responsible for its analgesic effects. Kappa receptors are involved in hypothalamic thermoregulation, and meperidine's activity at these receptors suppresses shivering through a mechanism that is distinct from its analgesic mechanism, and that other opioids, which are more selective for mu receptors, do not share as strongly. This specificity matters for the clinical risk calculation. A single 25 mg intravenous dose of meperidine given once for postoperative shivering produces a meperidine plasma level that is substantially lower than the levels achieved with analgesic dosing, and it is given once rather than repeatedly, meaning normeperidine accumulation is not a concern at this dose and frequency. The risk-benefit analysis for this single-dose application is genuinely different from the risk-benefit analysis for repeated dosing in post-surgical pain management, obstetric analgesia, or any of the other applications in which meperidine's use was rightly discontinued. So Demerol did not disappear entirely. It retreated to a single, narrow indication where its pharmacological properties are genuinely advantageous, and its risks are genuinely manageable, and where there is no comparably effective alternative. There is a certain irony in this. A drug whose career included being presented as the superior replacement for morphine in virtually every clinical situation now persists by virtue of a single property, kappa agonism, that nobody was thinking about when the drug was launched, and in a dose range that would barely register on the scales of its mid-20th century clinical use. It is, as retirements go, quieter than the career deserved. The American opioid crisis, which is usually narrated as a story beginning in the late 1990s with the aggressive marketing of OxyContin by Purdue Pharma, has a longer and more complicated prehistory that includes Demerol. The mechanisms are different. OxyContin's story involves a specific, deliberate corporate campaign built on misleading claims about extended-release formulations and addiction potential. But the underlying pattern is familiar. A drug is introduced with reassurances about safety that are not well supported. Those reassurances are accepted because they align with institutional convenience and the human preference for believing that medical progress is always forward, and the evidence of harm accumulates slowly against a background of institutional inertia until the weight becomes impossible to ignore. Demerol was not the cause of the opioid crisis, but it is a readable early chapter. The specific claim made about meperidine's addiction potential, that it was lower than morphine's EE, is a structural ancestor of the specific claim made about OxyContin's addiction potential, that the extended release formulation made it less liable to abuse. Both claims were made by parties with commercial interests in their acceptance. Both claims were accepted by a medical culture that wanted to believe in pharmaceutical progress. Both claims were wrong in ways that should have been testable before they became foundational to prescribing practice. And in both cases, the evidence of harm accumulated in the clinical record for years before it was sufficient to overcome the inertia of established practice. The parallel is not exact, and it is important not to overextend it. Meperidine's addiction liability, while real, was not the primary driver of its clinical harms. The normeperidine neurotoxicity was a separate and arguably more acute problem. OxyContin's harms were driven by addiction and overdose in ways that played out on a far larger scale and with far more visible and attributable deaths. The social and economic context of the two drug eras was different in ways that affected how the harms manifested and where they fell. But the epistemic failure, the acceptance of safety claims without adequate evidentiary support, in a cultural context that rewarded novelty and discouraged skepticism, was structurally similar. The medical establishment of 1945 that accepted meperidine's marketing claims about reduced addiction potential was operating with the tools and standards of its era, and those tools and standards were inadequate for the task. The medical establishment of the late 1990s that accepted OxyContin's claims had better tools available, and a historical record that should have suggested caution, and the failure to apply those tools is hard to excuse. What Demerol's long arc suggests is that the specific pharmaceutical catastrophe of the opioid crisis was not an anomaly, but an expression of systemic features of how drugs are introduced, evaluated, and retired in American medicine. Features that were present and functional before OxyContin, and that would require structural change, not just pharmaceutical change, to address. Demerol is a 60-year case study in the persistence of those features. The opioid crisis arrived when those features collided with a drug that was more potent, more heavily marketed, and more widely diverted than anything that had come before them. One of the reasons Demerol maintained its clinical and recreational appeal for as long as it did is grounded in genuine pharmacology rather than mythology. Intravenous meperidine reaches peak brain concentration faster than intravenous morphine, which means its onset of action in acute pain situations is perceptibly quicker. This speed of onset is not clinically irrelevant. There are situations in which faster relief is meaningful, but it also produces a subjective quality of effect that both patients and physicians described over many decades as somehow cleaner or smoother than morphine's. What they were describing was partly the euphoric quality of a rapid mu-opioid receptor activation, and partly the stimulant properties of early normeperidine accumulation before it reaches toxic levels. It felt better because it was, in a narrow and temporary sense, doing more to your brain. That the second half of that sentence should have been alarming was not always appreciated. Opioid receptors, the mu, delta, and kappa subtypes, are distributed throughout the brain and body, and their activation produces different effects depending on which subtype is engaged, where in the nervous system the engagement occurs, and the kinetics of how quickly and intensely the drug hits its targets. Mu receptor activation is responsible for the analgesic, euphoric, and respiratory depressant effects that characterize the opioid class. The speed with which a drug engages mu receptors after administration is a major determinant of its subjective impact. A drug that reaches mu receptors quickly produces a more intense and more reinforcing effect than one with slower onset, even at equivalent total doses. This is why intravenous administration is more reinforcing than oral administration, why heroin, which crosses the blood-brain barrier faster than morphine, produces a more intense rush than morphine, and why meperidine, with its faster IV onset than morphine, produced a more immediately impactful subjective experience. The normeperidine contribution to this picture is more complicated. At low concentrations, the concentrations present shortly after a standard dose, normeperidine produces mild CNS stimulation, a slight increase in alertness and energy that modifies the sedative analgesic quality of meperidine's mu receptor effects in a direction that many recipients described as more pleasant. The heaviness and sedation that characterized morphine's effect were attenuated in early meperidine exposure by this stimulant overlay. The overall experience was, for many people, genuinely preferable to morphine's, cleaner, less foggy, more functional. This was not an illusion. It was pharmacology. The difficulty is that this favourable subjective profile was produced by the same metabolite whose accumulation at higher concentrations caused neurotoxicity. The dose concentration curve for normeperidine runs from mildly pleasant stimulation at the bottom to tremors, agitation, and seizures at the top, with a middle range of mood disturbance and dysphoria that many patients receiving repeated doses described without being able to connect it to the drug. The stimulant quality that made early meperidine exposure feel different and better than morphine was, essentially, an early preview of the toxic syndrome that arrived when normeperidine accumulated to dangerous levels. The pleasant phase and the dangerous phase were caused by the same compound. Nobody who described meperidine as cleaner than morphine was making an error. They were just describing an effect without knowing what produced it. There is a dimension of the Demerol story that does not appear in pharmacokinetic studies or formulary committee minutes, but that is essential to understanding what actually happened to real people. For the decades during which meperidine was administered to labouring women, post-surgical patients, sickle cell patients, and cancer patients, the conversation about what the drug would do, what it might not do, and what metabolic processes it would set in motion was, in the vast majority of cases, not happening. Patients were told they were receiving something for pain. They were not told that the drug would cross the placenta and sedate their newborn. They were not told that repeated doses would build up a metabolite capable of causing seizures. They were not told that there were alternatives. Informed consent in the context of Demerol was largely a formality rather than a practice, and this was entirely normal for the era. Informed consent as a robust, clinical and legal doctrine is largely a product of the second half of the 20th century. Its modern form developed in response to a series of legal cases, ethical violations and professional reckonings that progressively established the principle that patients have a right to understand what is being done to them, why, what the alternatives are, and what the risks involved before agreeing to treatment. The Nuremberg Code of 1947 established the principle in the context of human experimentation. A series of American court decisions through the 1950s, 60s, and 70s extended it to routine clinical care. Canterbury versus Spence, decided in 1972, established in American law that physicians had an obligation to disclose the information that a reasonable patient would want to know before making a treatment decision, a standard that, taken seriously, would have required disclosing meperidine's placental transfer dynamics and metabolite accumulation risk to every patient receiving it. The legal framework existed. The clinical practice did not yet consistently follow it. The gap between the legal and ethical framework and the practice of obtaining informed consent for medication administration was, however, substantial. Physicians in clinical practice rarely provided detailed pharmacological information about the medications they prescribed or administered. The asymmetry of expertise. Patients lacked the background to ask precise questions. Physicians lacked the tradition of volunteering detailed information, meant that consent for medication was usually implicit and undiscussed. A nurse administering a meperidine injection to a labouring woman was not expected to explain the placental transfer dynamics, the fetal respiratory depression risk, and the comparison with available alternatives. She was expected to administer the medication ordered by the physician. The physician who ordered it was not expected to have a conversation about normeperidine. These were things that happened inside medicine, not between medicine and patients. The culture that made this possible was a medical paternalism that had been the dominant mode of clinical practice for most of the 20th century. In this model, the physician knew what was best for the patient. The patient's role was to comply with the physician's recommendations, and the provision of detailed pharmacological information was considered more likely to confuse and frighten than to inform and empower. This was not a cynical calculation. Many physicians genuinely believed that their patients were better served by confident, clear direction than by the kind of nuanced uncertainty that accurate pharmacological disclosure required. A patient told that the drug they were about to receive had a metabolite that could cause seizures in some dosing conditions would be frightened, and frightened patients were, in this model, patients who were not being well cared for. The kindness was real. The informational impoverishment it produced was also real. For patients who received Demerol in the decades of its widest use, the consequences of this informational gap were personal and specific. Women who had no memory of their childbirth did not know they had received a drug that could have produced that amnesia, or that the amnesia had been considered a feature rather than a side effect by the people administering the drug. Some of these women spent years believing that their disconnection from their child's birth was a personal failing, an emotional unavailability, an inadequacy of response, rather than a pharmacological outcome engineered by institutional medicine's approach to managing labour. The drug had done something to their experience and their memory of that experience, and nobody told them, and the gap in their narrative became their own to carry. Patients who developed seizures on day 4 of post-surgical care and were told they had an adverse reaction to their pain medication were not told that the reaction was a known consequence of the metabolic properties of the specific drug chosen, that it was a known consequence that had been documented in the literature for years, or that different analgesic choices would not have carried the same risk. They were told what had happened to their bodies. They were rarely told the institutional and pharmacological context that had produced it. The seizure became a fact about the patient. He had a seizure after surgery, rather than a fact about the drug. This drug, in this dosing pattern, in a patient with this clearance profile, produced a predictable toxic event. The first framing erases institutional responsibility. The second one allocates it accurately. Sickle cell patients who received Demerol during pain crises and later developed normeperidine-related neurological events were operating without the information they would have needed to advocate for themselves. A patient who knows that the drug they are about to receive has a toxic metabolite that accumulates with repeated doses, who has been coming to this emergency department with pain crises for years, who has received this drug many times. That patient, armed with that knowledge, is in a position to ask questions, to request alternatives, to insist on a conversation. Without that knowledge, they are simply in pain and accepting what the system offers. The system offered Demerol. The patients accepted it, because accepting what the system offers is what patients do when they do not know what else to ask for. The informed consent failure in the Demerol story is not unique to Demerol. It reflects a broader pattern in how medicine of that era related to patients, which was as recipients of care rather than participants in decision-making. The corrective to this pattern, the gradual development of patient autonomy as a genuine clinical value rather than a legal formality, arrived too late to change what had already happened. It did, however, arrive. By the 2000s, the shared decision-making model was established enough in medical culture that a physician prescribing meperidine to a patient who was asking questions faced genuine expectations of disclosure that their predecessors had not faced. This cultural shift, combined with the formulary removals of the same era, created conditions in which the information failure could begin to be addressed, not retroactively, not for the patients who'd already received the drug without adequate information, but prospectively, for everyone who came after. The patients who bore the cost of decades of inadequate disclosure did not receive an apology from medicine. They rarely do. What they received, eventually, was a system that became slightly less likely to make the same category of error again, which is the closest thing to accountability that institutional medicine has historically been able to offer. The story of how individual hospitals actually got Demerol off their formularies in the 2000s and 2010s is less dramatic than the pharmacology, and more instructive than most people expect. It typically began not with a catastrophic event, but with a pharmacist or a physician reviewing the ISMP guidance, pulling their own institution's adverse event data, and making a quiet, sustained argument to a pharmacy and therapeutics committee that the math did not work out in Demerol's favour. The arguments that met this proposal were not primarily scientific. By that point, the scientific case was largely settled. They were operational. What do we do for post-op shivering? What do we use for migraine in the ED? What do we tell physicians who trained on Demerol and trust it? The answers to these questions were available. The will to deploy them was the limiting factor. The Pharmacy and Therapeutics Committee is, in the governance of hospital medication use, the body with the most direct authority over formulary decisions and the body most likely to act on pharmacological safety evidence when it is presented clearly. P&T committees are typically chaired by a physician and include pharmacists, nurses, and physician representatives from relevant specialties. Their proceedings are formal but not adversarial in most institutions. The goal is consensus on clinical policy rather than adjudication of competing interests. When a pharmacist or a medication safety officer brought the meperidine case to a P&T committee in, say, 2007, they were presenting to a body that had the authority to act and that, in general, was composed of people genuinely motivated to provide good care. The presentation mattered, which is why the institutions that moved fastest were often those with pharmacists skilled in translating pharmacokinetic evidence into clinical language that physicians with no particular background in metabolism could immediately understand. The discussion at these committees followed a recognizable pattern that was documented in enough case reports in the pharmacy literature to describe with some confidence. The safety argument was presented. The evidence from the ISMP, from the institutional adverse event data, from the pharmacokinetic literature was laid out. The committee acknowledged the evidence. Then the operational questions began, and the timeline of action became dependent on how those questions were resolved. The shivering question had a ready answer. Meperidine would be retained on the formulary in a restricted form, available only for the shivering indication at the 25 mg dose, with a specific indication requirement on the order and a requirement for physician documentation. This addressed the clinical need without reopening the door to unrestricted prescribing. The migraine question was harder, because emergency physicians who'd been using meperidine for migraines needed to be shown the evidence that alternatives were equivalent or superior, and that evidence presentation required physician education efforts that added time and institutional energy. The physician education challenge was, in many respects, the most significant operational barrier. Telling a surgeon with 30 years of experience that the drug they have been ordering for post-surgical pain management, without incident from their perspective, should be discontinued required a kind of direct, respectful conversation about evidence and practice, change that hospital culture was not always structured to support. The physicians most resistant to the change were not unreasonable, and it is worth being specific about why. They had trained in a certain way, in a residency environment where Demerol was the default, and where the rationale for its use was transmitted as fact rather than as hypothesis. They had been practicing in a certain way for years, and their patients, as far as they were aware, had done reasonably well. They had not, in their direct clinical experience, observed the harms that the data described at the aggregate level, because those harms were diffuse, delayed, and attributed to other causes at the bedside. The argument required them to accept that the evidence base was telling them something that their clinical experience was not, which is exactly the kind of abstract data over experience argument that clinicians trained in the pre-evidence-based medicine era found genuinely most difficult to accept. This is not stubbornness for its own sake. It is a deep feature of how clinical knowledge is built and how it is revised, and it explains a great deal about why evidence-based medicine has sometimes advanced more slowly than its proponents expected. The hospitals that moved fastest shared identifiable characteristics. Strong pharmacy leadership was almost universally present. A director of pharmacy or a clinical pharmacy specialist who had invested in the meperidine issue assembled the evidence and was willing to advocate for change through the institutional channels available to them. Supportive hospital administration was important, particularly when physician resistance required leadership engagement to move forward. A clear alternative protocol, specific drugs, specific doses, specific indications, ready for immediate implementation, reduced the friction of transition by ensuring that the removal of Demerol did not create a clinical vacuum that physicians could point to as a reason to maintain the status quo. The hospitals that moved slowest were the ones where pharmacy leadership was thinner, where P&T committees were less active or met less frequently, and where the physicians most invested in maintaining meperidine access had the institutional authority to delay action indefinitely. In some community hospitals and smaller facilities, meperidine remained on the formulary years after academic medical centres had removed it, not because the evidence was different, but because the institutional machinery for acting on evidence was less developed. This is an important observation about healthcare quality in general. The same evidence, applied in different institutional contexts, produces different clinical outcomes at different speeds. The safety of patients in community hospitals is not inherently worse than the safety of patients in academic medical centres, but the speed at which safety improvements reach them has historically been slower, and meperidine's removal timeline illustrates that gap clearly. What eventually resolved even the most prolonged discussions was usually a combination of three things arriving at approximately the same moment. Strong pharmacy leadership making a clear, persistent argument. Enough institutional adverse event data to make the problem visible and specific, rather than abstract and statistical. And the gradual retirement of the clinical generation most attached to the old protocols. This last factor sounds cynical but is simply accurate. Practice change in medicine is often generational in a literal sense. The physicians who trained on Demerol, who'd built it into their clinical identity, who delivered confident speeches to medical students about its advantages over morphine, were not generally the physicians who drove its removal. They were the ones whose resistance had to be accommodated and managed, until time produced a clinical culture that found Demerol's continued presence as puzzling as it had once found its elimination threatening. Medicine changes, as it often does, at the speed of retirement. And so here we are, at the end of a very long night in the history of medicine. You have travelled through 1939 Germany and 1950s American hospital wards, and the labour and delivery rooms of 4 decades, and the emergency departments that held on longest, and the nursing charts where the warnings accumulated long before anyone with authority was reading them. You have met a molecule that arrived with extraordinary confidence, wore its marketing claims like a clean white coat, and spent 60 years quietly doing things to human nervous systems that nobody at the bedside was supposed to connect back to the syringe. It is a long story, and it is a quiet one, which is part of why it took so long to tell. The loudest pharmaceutical stories are the ones that end in headlines. This one ended in committee minutes and formulary revisions and the slow retirement of clinical generations who had been trained in a world where Demerol was simply what you reached for. Think about the people in this story. Not the committees, not the regulatory bodies, not the pharmaceutical companies or the pharmacy directors or the ISMP working groups. The people. The woman who woke up after giving birth with no memory of it, who spent years believing that absence was hers, a personal failure of emotional presence at the most significant moment of her life, rather than a pharmacological outcome engineered by institutional medicine's approach to managing labour. The post-surgical patient on day 4 whose hands were trembling and whose world was narrowing and who had no language for what was happening because nobody had given them any. The sickle cell patient who had been coming to the same emergency department for years in genuine and severe and documented pain, receiving the same drug each time, accumulating something nobody measured until the day the threshold was crossed and the seizure came, and even then, even in that moment, the connection was not always made. The nurse who wrote it down in the chart, who connected the tremor to the medication, who raised the concern to a physician who attributed it to something else and moved on, who wrote it down again the next shift because it was still there and still not explained. These people are not statistics, even though the story of Demerol can only be told at scale. Each one of them had a body that was doing its best with the chemistry it was given, and the chemistry it was given was not chosen with full knowledge of what it would produce. That is not comfort. It is just the truth. And the truth, in medicine as in most places, is the beginning of whatever comes after it. Medicine is one of the most extraordinary human projects ever undertaken. The ability to enter another person's body with knowledge and intention, and relieve their suffering, to extend their life, to restore their function, to sit with them in the place where the body is failing and offer something useful. This is not a small thing. It deserves the reverence it receives, and the people who dedicate their lives to it, who study for a decade and work for 60-hour week and carry the weight of other people suffering home with them at night, those people deserve genuine, unconditional respect. That respect is not in tension with accountability. It is, if anything, the reason accountability matters. The higher the stakes, the more important it is that the systems are honest about what they know and what they do not, and honest about the distance between those two things. The Demerol story is, at its core, a story about that distance, between what was known and what was communicated, between what was documented and what was acted on, between the publication of a case report describing normeperidine-related seizures in 1968 and the formulary removal at a typical American hospital 35 years later. The distance is not filled with malice. It is filled with institutional inertia, professional habit, inadequate surveillance systems, marketing claims that aged badly, and the entirely human tendency to trust what has always been done because it has always been done. None of these are villains. All of them are hazards, and the patients who passed through that distance paid for it, with their bodies and their memories, and in some cases, with outcomes that should not have been the outcome. They deserved better information. They deserved faster action. They deserved a system that was as urgently organised around removing harmful things as it was around adopting new ones. They also deserved the acknowledgement that their experience mattered, not as a data point, not as an adverse event report filed in a voluntary reporting system and weighted against competing considerations, but as a human experience that happened to a real person who trusted the institution and was not always well served by that trust. History is very good at telling stories about breakthroughs, the discovery, the innovation, the drug that changed everything, the scientist whose name goes on the textbook chapter. It is considerably less practiced at telling stories about the long, quiet, diffuse harms that accumulate between the breakthrough and the reckoning. Demerol had both. The breakthrough was real, a synthetic analgesic in 1939 that opened an entire new chemical territory in pain management, that demonstrated for the first time that opioid activity could be produced by a molecule that bore no structural resemblance to the poppy, that was genuinely significant. The harm was real too. Holding both of those things at once, without letting one cancel the other, without letting the excitement of the discovery excuse the slowness of the correction, is what honest medicine history requires. It is also, it turns out, harder than it sounds. What Demerol leaves behind is not only a warning about one specific molecule, it is a template for recognizing a type of failure that recurs, a drug introduced with incomplete safety data. Safety claims accepted because they were convenient, evidence of harm accumulating in the literature faster than it accumulated in practice change. Patients absorbing the cost of the gap. Eventually correction, always eventually. The question that the story asks and that medicine has been working on with variable urgency ever since is whether eventually can become sooner. Whether the systems can be made more sensitive to early signals. Whether the institutional machinery for removing a harmful drug can be made to move at something closer to the speed at which the evidence moves. Whether the patients who are receiving a drug right now in a hospital somewhere that has properties not yet fully understood will wait decades for the reckoning or years. The answer in 2025 is that it has gotten somewhat better. Somewhat is not nothing. Somewhat is also not enough. So tonight, as you settle into whatever comfort surrounds you, the mattress that holds the shape of you, the temperature calibrated to your preference, the absence of pain that you may or may not notice, because absence is always quieter than presence. Consider for a moment what it means to be a patient. To hand your body to a system and trust that the system is doing its best with what it knows. The people who received Demerol did exactly that. In many ways, the system was doing its best. In measurable, documented, prolonged, and eventually corrected ways, its best was not good enough. The distance between those two things is the distance between medicine as it is practiced and medicine as it aspires to be, and closing that distance is the work that never finishes, that each generation of physicians and pharmacists and nurses and regulators inherits from the last and passes, slightly reduced but never eliminated to the next. Rest now. The history will still be there in the morning. So will the questions. And so, stubborn and essential and impossible to retire, will the effort to do better. One molecule, one case report, one nursing note, one committee meeting, one honest reckoning at a time. That effort is the best of what medicine is. Hold on to it. It is the thing worth keeping.